So today we're going to talk about the multiple angle identities. We're going to do two types. We're going to do the double angle and the half angle identities. We're going to talk about simplifying some things with it, finding out some values, and then we're also going to talk about solving some equations. So that is what we're going to talk about in Lesson 5.5. The first set of identities we're going to talk about are the double angle identities. The sine of 2 theta, the tangent of 2 theta, the cosine of 2 theta. Now, one thing to note is the cosine has 3 different versions. The reason that the cosine has so many versions is because of the relationship between sine squared and cosine squared. You kind of can just pick whichever version works best for that particular problem. But these are what we're going to use to double the angle inside. And we're going to look at some examples of how these identities work. So here's an example of the first application of our sine double angle, cosine double angle, and tangent double angle formulas. So all that they have given us is that the sine is 3/4, and it's on the interval from 0 to pi over 2. So that just means it's in the first quadrant, okay? Now, the reason you want to know that is because if it's in the first quadrant, we can draw a little picture. If you recall, if we are on the terminal side of an angle in the first quadrant, we can draw the little triangle in there. Theta is always a connection from that point to the origin, and theta is always closest to the x-axis and that hypotenuse. If you look, if the sine is 3/4, we know our opposite is 3. We know our hypotenuse is 4. And so let's go ahead and look at what we need from there. So let's begin finding the sine of 2 theta. Now, the formula for the sine of 2 theta is 2 sine of theta cosine of theta. So if you were to complete the Pythagorean theorem with the numbers we know in our triangle, we know that our adjacent side squared, let's just call that x squared, plus 3 squared equals 4 squared. 3 squared is 9, 4 squared is 16, 16 minus 9 is 7. So it's the square root of 7. It's technically plus or minus the square root of 7, but when we are in the first quadrant, that is positive, okay? So the sine of 2 theta is 2 times the sine value times the cosine value for the original angle theta. Well, our original angle theta, if you look and we find the cosine is adjacent over hypotenuse, so that would be square root of 7/4. Now, we want these exact values. We don't want any type of decimal, so you don't want to enter these into a calculator. You just want to simplify them as much as you can. And when simplified, we get 3 radical 7/8, because the 2 cancels out one factor of 2 in the denominator. Now that's the sine of 2 theta. Now let's do the cosine of 2 theta. Now you might recall that the cosine has 3 formulas that we can choose from. I like the fact that they originally gave us a sine, and the formula that contains only a sine for a cosine of 2 theta is 1 minus 2 sine squared theta. So why not use the formula that contains the information they gave you right off the bat, which was the sine of theta? Excuse me. So we get 1 minus 2 times 3/4 squared. Well, 3/4 is 9/16. So that becomes 9/8, and that's 8/8. So that's negative 1/8. Now, let's think about why possibly our cosine value became negative. Well, if theta was in the first quadrant If we double it, we have the 50-50 shot of landing in the second quadrant. So what happened was, that's exactly what happened. Our theta was in the first quadrant. We doubled it, and cosine went to the second quadrant, and in the second quadrant it's negative. So it makes sense that it might be a negative value. Now the last one they gave us was, or they asked was, the tangent of 2 theta. The tangent of 2 theta is 2 tangent of theta minus 1 tangent squared of theta. But tangents, we know, are a combination of sines and cosines. So you can use the formula, but wouldn't this just be the sine of 2 theta over the cosine of 2 theta? They asked us for the sine of 2 theta and the cosine of 2 theta already anyway. So let's just put the sine of 2 theta, which is 3 radical 7 over 8, over the cosine of 2 theta, negative 1/8. The 8's are in a perfect spot to cancel, so it becomes negative 3 radical 7. Now let me prove to you that that works, and that the formula also works, which was 2 tangent of theta over 1 minus tangent squared. Now the reason I didn't want to do it because I didn't know the tangent of theta, but if you look here in your triangle, tangent is opposite over hypotenuse, so that's 3 over radical 7. I'm just going to kind of leave it like that for a minute. Okay. So if we use the formula for the double angle, we get 2 times 3 over radical 7 over 1 minus that tangent value, 3 over radical 7 squared. Do you see how it's just a little clunkier, you know, as far as simplification purposes go? So let's look. We get 6 over radical 7 over, let me scooch this over so I have more room. This would be 1 minus 9 over 7. So that would be 7 sevenths minus 9 sevenths is negative 2 over 7. And then let's do big C over little c. So that would be 6 times 7 over negative 2 radical 7. You'd have to rationalize. 2 goes into 6 3 times. When you rationalized, okay, so we'd get negative 3. We'd have a 7 up there. We'd get, this would pop to the top and leave a normal 7 behind. The 7's would cancel. We'd get negative 3 radical 7. Do you see how that formula is almost grosser than just doing sine of 2 theta over cosine of 2 theta? So one of the pieces I would probably add to this list of formulas here for tangent, you might want to make yourself a note that this is also the sine of 2 theta divided by the cosine of 2 theta. Now the 2's are stuck inside there, inside by the theta. They can't come out, they can't simplify. They are stuck inside, so don't try to simplify the 2's. They mean you're doubling the angle that's inside the sine or the cosine or the tangent. Okay, so there's our first example. Okay, now let's go and move on to the next example. Now the last example was just taking an expression, finding what the values are, you're done. Here it's an equation to solve. Now remember, the way that you solve an equation is to find out what values on the unit circle work. That's what you're really asking yourself. So if you look at this problem, here's the issue. One of your angles is a 2 theta. One of your angles is a theta theta. They don't match. You want, when solving a trig equation, you want the thetas to match, the angles to match, and you also want, if possible, to be either able to factor it or for the trig function to match. So I don't like the fact I've got a cosine of 2 theta there. Cosine of 2 theta has 3 possibilities, okay? I'm going to choose the possibilities that match the trig function in the problem. Look what's in the problem. In our problem, we've got a cosine sitting right there. So we want to get this to match this particular trig function. So we need this to be replaced with whatever contains only cosines. Well, of the 3 things to choose from, I'm going to choose this to be replaced with 2 cosine squared theta minus 1. Because what does it accomplish? It gets me trig functions that are only cosines of theta and no other trig function. And it will match the trig function that was already in the problem, cosine of theta. Now, I don't like the fact that this is equal to 2. You want it equal to 0. So let's subtract 2 from both sides. We get 2 cosine squared theta minus cosine theta minus 3 equals 0. So all I have done is I've got it equal to 0 and I've put it in descending order. Now this is a perfect candidate for u substitution. If we let u equal the cosine of theta at this point, we're going to put it here and here. We get 2u squared minus u minus 3 equals 0. We're going to try to unfoil or factor that. It is a factorable quantity. Let's think for a moment. If we did slide and divide, 2 times 3 is 6. What are the factors of 6 that will add up to -1 in the center? -3 and 2 is what we're looking for. So this is going to factor to be 2u and u. You want this to be a -3 and this to be a +1. Now if you forget y, just think outers and inners. The outers and inners should combine to give you the middle term sitting right here. This middle term right there. Okay. They do that. -3 plus +2 is the negative u we're looking for. So we're good to go. Now solve each one individually. You get 2u equals 3, so u equals 3/2. And u equals -1. Put your cosine back in. You are not done at this point. Now we ask ourselves, where does that occur on the unit circle? The cosine will never be something more than 1 or less than -1. It's always stuck between those values. So this first piece is gone. That negative, or that 3/2, it will never equal 1.5. That's too much. So that one's gone. We don't have to worry about that. The cosine equals -1 only at one particular location, and that would be at pi. So our angle measure, our thetas, are pi's. So that is how you do an equation using these formulas. Now let's look at our last type of identities for this section. Here are the half-angle formulas. You will notice just like our cosine of 2 theta had 3 different versions, the tangent actually also has 3 different versions. They will all be equivalent. They will all give you the same exact answer. It's just a matter of what are you trying to look for. What values have they given you? If they've only given you a cosine, you'd probably use the first one. But if they've given you both, either the second or third one works. So here's an example where you would use the half-angle formula. Now, how would you know to use the half-angle? Well, 22.5 excuse me, is not on the unit circle. But think about what is. If you double it and get 45, 45 is on our unit circle. So if we don't think about this as 22.5, but we think about this as 45 divided by 2, we can use the sine of theta over 2 formula in order for us to make it work. Now, the half-angle formula is plus or minus the square root of 1 minus cosine theta divided by 2. Now, how do you decide if it's the plus or the minus? Well, that's from your knowledge on the unit circle. So where does 22.5 land? It lands in the first quadrant. So it's positive. So in this particular case, we would choose the positive value. If it was a sign in the third or fourth quadrant, we would choose the negative. So you do have to use some of your knowledge about the unit circle. So wherever theta is in this formula, we're going to put our theta of 45. We know what 45 is from our unit circle. So it is going to be positive square root of 1 minus the square root of 2 over 2 over 2. Now, how did I get the square root of 2 over 2? Well, that's the cosine. I kind of skipped a step there. The cosine of 45 goes right here, and that is square root of 2 over 2. So I just put that in there, okay? Now, that's gross. But how can you figure that out? Well, let's multiply here on the top and the bottom times 2 to make it look more like a fraction should. And we get the positive square root of 2 minus radical 2 over 4. Now, we don't always see many places where we have radicals inside of radicals. Here is one of those places. That's your answer. You're done. There's nothing else to do. That is see the word here? And I've tried to remind you of that again and again. When they say exact value, we want those square root values. We want those fractional values, and we want to stop. We don't want to have to enter things into a calculator, and that's our goal here. I didn't have to enter the sine of 22.5 into a calculator. I could just figure it out using one of these formulas. And let's do one more, last example. Here is a formula. Well, you know what? These are the, yeah, we can do this one. Okay. So, you will notice that this side has a sine squared in it of x. But the other side has a half angle in it. Why? Because it's x divided by 2. If we look at our half angle formulas, are, we have 3 different versions for tangent. I am going to choose the formula that contains just one trig function and only one trig function, and that would be the cosine formula. So this is going to be the square root of 1 minus cosine over 1 plus cosine. And normally that formula has a plus or minus in front, but I'm going to be squaring it, so it's only going to contain a positive. Who cares? A negative or positive squared will be a positive. Now, my left side has a sine squared in it. I don't want that. I need cosines in that too. So that is equal to 1 minus cosine squared. And I'm sorry, my variables should all be x's. erase that, make that look nicer. Okay, so let's think about when we square the right side. We're going to get 1 minus cosine squared on the left. The right side, the square root pops out. We get 1 minus cosine of x over 1 plus cosine of x. This is an equation. We need to cross multiply. So this needs to multiply over there. Put the left side in parentheses to remind you that we're going to have to FOIL that. And here, let me make this look a little nicer. So we're going to have to FOIL 1 plus cosine times 1 minus cosine squared. When we do that, on the left side, we're going to get 1 plus the cosine minus cosine squared minus cosine cubed equals 1 minus cosine. This is an equation that probably is going to require us to get it equal to 0. I look at find your highest power. You see how my highest power there is negative on the left side? So using algebra, let's take all of this to the other side and make that side equal to 0. So everything on the left, I'm going to change the sign and add it to the right. Okay, so I'm going to subtract 1. I am going to, let's start with the highest power, cosine cubed. So I'm going to have a cosine cubed. Then next I'm going to have a positive cosine squared. I'm going to subtract a cosine. There was already a cosine there, so that's minus 2 of those. And then my positive 1 becomes a negative 1 and subtracts and becomes a 0 on the other side. Okay. Now, anytime you have something equal to 0, the best way to solve it, if you can, is to factor it. This can be factored by factoring out a cosine. We get cosine squared plus cosine minus 2. That still is a factorable quantity in parentheses. That's cosine of x plus 2 minus 1. We have three quantities of which they all will get their own 0 equation. So we're looking at where is the cosine of x equal to 0? That's the first one. Where is cosine of x plus 2 equal to 0? Where is cosine of x minus 1 equal to 0? Now the first one is solved for us, but remember, we're not done. You have to find and ask yourself, where does that occur on the unit circle? The cosine is equal to 0 in 2 places, 90 and 270, but leave that radians for me, pi over 2 and 3 pi over 2. The second equation gives me that the cosine of x equals negative 2. That will never happen. Remember, the cosine is always stuck between positive 1 and negative 1. So negative 2 is out of the possibilities for a cosine. If you tried to inverse that on a calculator, it would say error. Like if you hit second cosine or inverse cosine of negative 2, it would say error, and that's why. This last one, the cosine of x is equal to 1 in just one place. That is 0. It's also 2 pi, but look at the way that they've written our interval up here. They've written our interval with a parenthesis on the 2 pi, so you don't have to include it. If it had a bracket on the 2 pi, you'd include it. So our answer is pi over 2, 3 pi over 2, and 0. Which is D. So that's how you use some of these new formulas. Here is the assignment that goes with it. Good luck to you. Thanks.